Hi guys, and welcome back to Viable Futures. In this video, I will be sharing my background research on the metallic 3D printing sector, and then discussing Desktop Metal, a company Chamath Palihapitiya has recently been tweeting about. I want to briefly discuss some of Desktop Metal's main competitors, and put forward some views on why Chamath is backing this stock specifically. As always, the note that I am not a manufacturing expert, and I have done my best to make this video suitably detailed and accurate to understand the investment potential of Desktop Metal. If I have made any errors or oversimplified, then I apologise and ask that you do let me know in the comments, as I am always keen to learn. Oh, and the standard request of please like the video, if you do in fact like the video. Now, I can't understand why this industry isn't being talked about more often. It is pretty clear to me now that we are on the verge of a manufacturing revolution. I think the impact 3D printing will have on the manufacturing sector will be similar in relative scale to the impact electric vehicles are having on the automotive sector. The majority of people will have heard of 3D printing, but for those that haven't, 3D printing, or additive manufacturing as it is called in the industry, is the process of constructing an object by depositing material in very thin layers, layer by layer, until the desired shape is formed. The process of additive manufacturing has been around in useful form since the 1980s, and was mainly used for prototyping. Only recently have the machines, or the printers, that produce 3D objects been suitably advanced that additive manufacturing has become a viable option for industry for mass production. The manufacturing industry is a $12 trillion US giant, which accounts for 60% of the US GDP. Additive manufacturing is set to revolutionise this industry, and if the current expectations are met, there is a lot of money to be made. Additive manufacturing seems to be moving more and more into the tech spotlight. Perry, 3M and others are printing houses. SpaceX is printing the Raptor engines, and Ford is using metal 3D printing to drive the automotive factory of the future. The automotive and aviation industries are examples of sectors which are turning to AM as the advances in the technology are already making their businesses and products more efficient. This comes in the form of supply chain efficiency by either reducing the number of suppliers or by vertically integrating the suppliers and bringing the process in-house, but it also comes from the ability to combine parts that was previously not possible. A famous example that is widely cited was back in 2016 when Airbus was able to produce fuel nozzles using additive manufacturing. The AM process was able to produce the nozzle, reducing the number of parts from 20 down to 1, saving 25% of the weight and reducing the assembly time. To understand why additive manufacturing is going to revolutionise the industry, it's important to first understand how the parts are currently being made. Simply put, there are two main methods: casting and machining. Casting is where molten metal, usually aluminium, copper, zinc or an alloy, is forced into a steel die or mould that contains a hollow cavity of the desired shape and allowed to cool. The die is then removed and the product is formed. Machining is where you start with a block of metal and cut out the product you want. Machining is often used to shape the moulds used in the casting process. A key limitation to machining and casting when compared to additive manufacturing is the constraint on the shape that can be made. With machining, a designer is limited to producing a shape that the cutting tool can reach. With casting, the designer is limited again to producing a shape that the molten metal can reach. So a designer needs to consider the manufacturing process when they are producing their designs. A designer may be able to come up with a leaner, more efficient design, but if it can't be actually made, then it's pointless. So what is so great about additive manufacturing? Well, put simply, AM is a transformative approach to industrial production and made possible by the transition from analog to digital processes. It uses computer models to direct hardware, the printer, to deposit material layer upon layer in very accurate shapes. As the name applies, additive manufacturing adds material to build up an object. It is proving to produce cheaper products, provide a more flexible design phase where prototyping and design changing is quicker. It produces a lighter, more lean design and can provide supply chain efficiency. Structures can now be produced where material is only deposited deposited where material is needed. Designers are becoming free from the shackles of casting to produce products that were never possible before. And this is one of the main reasons why lighter products are being produced. But another key reason is due to supply chain efficiency. The fuel nozzle example mentioned earlier used to require 20 different parts. Possibly from different manufacturing companies across the globe, these parts would probably need to travel to another factory to be assembled. To assemble the part would either be welded or bolted together. All this adds weight, making a product less efficient. 3D printing or additive manufacturing is able to produce these complex shapes in one, reducing the number of connections and thus producing the weight. And we must now talk about artificial intelligence, because I see this as another key factor for the migration to AM. Artificial intelligence is being integrated into design software packages, further assisting designers in producing the designs that are a lot more efficient. It has been suggested that the CAD technicians of tomorrow will be able to produce more efficient designs than the top designers of today, all thanks to AI. We are starting to see products and structures look more like things in nature, like tendons in the human body, and this is because AI is able to determine the most efficient form of a structure and ensuring material is only present where it's needed. Now, it's really important to stress at this point that additive manufacturing isn't going to suddenly make casting and milling redundant. It should be seen as a powerful addition to these existing methods. But as additive manufacturing technology develops, I do believe we will be seeing a significant shift from the traditional methods towards AM. Now, there are 7 main types of additive manufacturing methods, and I think it's important to briefly discuss them, as it won't become apparent why Desktop Metal's products are superior if you have nothing to compare them to. Now, the 7 types are laser-powered bed fusion, material extrusion, binder jetting, directed energy deposition, material jetting, sheet lamination, and vat polymerization. Now, I only really want to go into detail on the first 3 of these, as they are generally the main ones in the industry. So laser-powered bed fusion is by far the most widely used method currently, and it involves directing either a laser or electron beam to melt and fuse metal powder together. Once the first layer has been melted and fused together, another layer of loose metal powder is added, and the laser starts up again, adding to the next layer. Material extrusion is where metal is drawn through a nozzle, heated, and is then deposited layer by layer. The nozzle moves horizontally, and the platform moves up and down vertically after each layer is deposited. And binder jetting is similar to the standard inkjet printers we know today. A printer head moves from left to right, depositing 2 materials, a metal powder and a binder. Once a layer is added, it's dried, and the object is lowered, and the next layer is added on top. Once the object is printed, a couple of post-processing steps are required. The first is the curing stage, which increases the strength of the part so it isn't destroyed, in the next stage called sintering. So after curing, the part will be highly porous, and the metal part is relatively weak. Sintering is where the part is placed in a furnace and heated for approximately 24 hours until the binder is melted away and the metal is fused together. Now, I don't want to go into too much detail on the pros and cons of each system, but there are 2 key points I do want to make. Binder jetting is fast, way faster than laser-powered bed fusion and metal extrusion. With binder jetting, each layer can be printed with rapid speed, just like a sheet of paper. Whereas with laser or extrusion, you are constrained by the single laser or nozzle head, and the speed is much, much slower. Now, binder jetting may be much faster, but it does require the sintering process, which takes time. Currently, I see this as one of the bigger constraints to binder jetting, but with the rate of innovation, I think we will see this become more and more efficient and less of an issue. Desktop Metal have selected the binder jetting method for their production system. They say it is over 100 times faster than that of a laser-based system, finally bringing down the cost by significantly increasing productivity. So who is Desktop Metal? Well, it's a company founded in 2015 by leaders in advanced manufacturing, metallurgy and robotics to make 3D printing accessible for all engineers, designers and manufacturers. On the 10th of December 2020, DM went public through a SPAC, and the deal valued DM at $2.5 billion US. The transaction provided up to $575 million in gross proceeds, comprised of the SPAC's $300 million of cash and a $250 million US fully committed common stock pipe, which Chamath said he led. Existing shareholders will retain 74% of the company, with the SPAC's trust shares holding 12%, pipe equity at 11%, and founder shares at 2%. DM has produced 4 main products. The fibre, the shop and the studio systems are now all released, with the production system due for release in the second half of 2021. The production system is the most exciting and is really the first 3D printing system for mass production. Like the shop system, it uses a single-pass jetting technology, which makes it the fastest printing system in the world, delivering that 100x efficiency mentioned earlier. It produces excellent quality, competitive costs, repeatability, and supports a wide range of metals. For me, the takeaway here is that DM has now produced a product that provides better value to the traditional methods for certain applications. Their single-pass jetting technique is industry-leading, and I can see this company innovating quickly. And bearing in mind that the 3D printing sector has barely scratched the surface of what the sector believes is possible, this machine is very exciting and a key stepping stone to future revenue streams. ARK Invest believes that additive manufacturing is still in its infancy. Here we can see that AM is fairly well established in the prototyping sector, achieving a 40 to 50% market penetration. However, the real money is in the end-use parts, where ARK estimates that there is $490 billion US market potential. AM is currently only penetrating 1% of this. ARK's research also suggests that AM will grow to a $97 billion industry by 2024. That's an annual rate of growth of 65%. This chart shows a plot of existing technologies, with geometry complexity on the x-axis and quantity on the y-axis. The plot bubbles show a comparison of traditional manufacturing techniques and laser powder bed fusion as an example. Now, overlaid is how Desktop Metal's products will compete and disrupt this whole sector. Desktop Metal is very well positioned to lead this industry. They expect the AM market to grow 11x over the next decade, and their first 3 products are already on sale, with a production system due for release in the second half of this year. Their products are very energy efficient, plug and play, and they provide almost zero waste in the printing process. As such, DM have positioned themselves very nicely to take this sector growth in their stride. Another key reason that they are well positioned is they already have a global distribution network in over 60 countries, and their customers are all in the main sectors from automotive and aerospace to heavy industry. In an interview last year, their CEO stated that they're exceedingly happy that their customer base is very horizontal and that no customer accounts for more than 10% of their revenue. The leadership of DM is talented and is founder-led, headed by Rick Furlop. Rick is a serial entrepreneur who is the founder of 6 technology companies. And Forbes has called Eli Sachs, co-founder and technical fellow, the living embodiment of 3D printing. Many of the team are engineers, and more than 25 employees hold PhDs relevant to this sector. Now touching on the financials, and this is year-end 2019. The company achieved $26.4 million in revenue, and they expect this to increase to $941 million by 2025. Now this seems ambitious. Currently, approximately 86% of revenue comes from studio systems with consumables and 14% from software and support services. It's going to be interesting to see what the revenue percentage is for the production system when we get the interim results this year. To note, 89% of revenue is generated in North America, and key customers include BMW and Ford, who have both provided investment into Desktop Metal, but also Google, the US military, Lockheed Martin and Bosch. The company made a loss of $121 million, but are expected to make a profit of $508 million by 2025. The company has $625 million in cash and $9.9 million in debt. So, would I invest in Desktop Metal? Time to pull out the 3 questions. Is this really addressing a fundamental human need? I think it absolutely is. Additive manufacturing is able to facilitate leaner designs, decrease cost, reduce weight, reduce waste, and shorten the time to production. As such, AM provides a more sustainable method of manufacturing and opening manufacturing up to the masses. Could this be used by 1 billion people in 30 years' time? Absolutely. I'm confident that in 30 years' time, a large proportion of the human population that buys a manufactured item will find that the majority of that item will have been 3D printed. And Desktop Metal is currently positioned very nicely in this sector. And is there somebody really special here? Well, there is a highly qualified team led by some of the leaders in the industry, and most with an engineering and manufacturing background, backed by legendary investors. This is a strong hand. Now, for the key risks. Number 1, the competition. There are many AM companies out there, but very few that are providing even comparable systems though. Companies to watch are HP, who are expecting to announce a binder jet printer soon, X1, 3DO, Stratasy, Velo3D and Digital Metals are all other key players in this area. X1 is worth touching upon in a bit more detail. They, for a time, had the fastest printing system on the market, and they have a history of experience, and their latest model is the 10th iteration. This should not be dismissed. I also think that their revenue projections are ambitious, but Chamath has included their revenue predictions in his one-pager, so I'm going to trust him on this one. And finally, DM's production system is the first iteration of this size printer for them. It looks fantastic, don't get me wrong, and although the people at DM has fantastic experience, it is a relatively new company and the first iteration of this size product on the market. This can also be a positive, so let's see. Now, I have a position in Desktop Metal. I think this is a relatively safe, long-term investment. They currently have cash, and it is widely rumoured that they are eyeing up competitors for acquisitions. The share price today is approximately $20, and I'm looking forward to rewatching this in a few months' time to see if my thoughts have changed and to see how the stock price is trending. I should also mention that for those that prefer to invest in an ETF, ARK Invest have a specific ETF for 3D printing, worth checking out. Surprisingly to me, Desktop Metal isn't included in this, and I really can't understand why. Any thoughts? Please let me know in the comments. And a huge point I forgot to mention earlier, and this actually may be one of the biggest points for the sector. Saving the best till last, I guess. No tariffs. Designs can be sent across the world for free and printed in the country of assembly. This in itself is just so important to factor into the future viability of the sector. Now, I appreciate this video was a bit longer than the others, and I didn't set out to make it this long, but felt it was necessary to cover this in detail. But this really only scratches the surface of the sector, and I have very much simplified some areas. But if you found it useful, please do like the video and subscribe to the channel, as it really, really helps, and it brings a smile to my face. Thank you for watching, and see you in the next one.